Welcome to Maths and Science by IITian. In this lecture, I am continuing with the complex numbers because many equations in engineering, sciences at Olympiad level and JEE level, they do not have direct real number solution. Hence, complex numbers will form the importance, and for that I have taken a very good example. Cos x to the power of cos x is equal to e to the power of e. We have to solve this. How to solve this? This is the point of contention in this lecture. Let us try to solve this equation. What is the question given? Cos x to the power of cos x is equal to e to the power of e. We know the value of e. Here solution. We know the value of e is equal to 2.718. That implies e to the power of e is greater than 1. That implies cos x to the power of cos x should be greater than 1 to get a real solution. But cos x is less than 1. Cos x is always less than or equal to 1. That we know from Pythagoras theorem. Cos x cannot be more than 1. Hence, cos x to the power of cos x cannot be more than 1. Which implies there is no real solution. Real solution is not possible. Then we have to go for complex solution. Next step is to go for complex solution. In complex numbers, if they are in a complex plane, if there is a solution, let us try to find out. Here given is cos x to the power of cos x is equal to e to the power of e. That implies when you compare the powers or these values, these powers or this base value, this implies cos x is equal to e. Is it possible? In real numbers it is not possible. But in complex numbers, let us see. What is cos x? E to the power of ix is equal to cos x plus I sin x. That much we know. E to the power of minus ix is equal to cos x minus I sin x. Adding these two, we will get e to the power of ix plus e to the power of minus ix is equal to 2 cos x. That implies cos x is equal to e to the power of ix plus e to the power of minus ix by 2. But from the given problem, we know that cos x is equal to e. That implies e to the power of ix plus e to the power of minus ix divided by 2 is equal to e. That means e to the power of ix plus e to the power of minus ix is equal to 2e minus ix is equal to 2e. That means what is the problem we have to solve? E to the power of ix plus e to the power of minus ix is equal to 2e, for which x is to be found out. Let e to the power of ix is equal to z, which implies z plus 1 by z is equal to 2e. That implies z square plus 1 divided by z is equal to 2e. That implies z square minus 2ez plus 1 is equal to 0. You just see how easily we are able to find out the solutions in the complex plane when the solutions are not available in the real line. This I want to show you. For this I have taken up the solution problem. We cannot just say that there is no solution for cos x is equal to 2e. Cos x is equal to e. There is a solution. May not be in real, but in complex plane it is there. Z square minus 2ez plus 1. It is in the form of ax square plus bx plus c is equal to 0. That means x is equal to minus b plus or minus square root of b square minus 4ac by 2a. That is equal to what is b? b is minus 2e. Hence it can be written as 2e plus or minus square root of 4e square minus 4ac is 4 into 1 into 1, that is minus 4, whole divided by 2 into a is 2 into 1. That implies x is equal to, or we can say here z is equal to, rather. When we are getting the derivative from ax square bx plus c, you know this is the formula, that is in that form. Then we will get the z value, because z square minus 2ez plus 1 is equal to 0. Z is equal to e plus or minus square root of e square minus 1. But we assumed that z is equal to e to the power of ix. By taking logarithm on both sides, ix is equal to ln z. That implies x is equal to 1 by I into ln z. That implies x is equal to what is ln z? Ln z is nothing but logarithm of ln of e plus or minus square root of e square minus 1 whole divided by I. For a general solution, we will add 2 pi I n. Therefore, for a general solution, this 2 pi n is added only for the general solution. For n is equal to 0, n is equal to 2, n is equal to 3, n is equal to 1, like that. Then x is equal to, we can simply write this also, no problem. Minus I ln e plus or minus square root of e square minus 1 plus 2 pi in for the general solution. 2 pi n, sorry. I into I is equal to minus 2 pi I. Or we can, we need not put 2 pi in also. Why unnecessarily it is causing confusion means for you. Then x is equal to ln e plus or minus square root of e square minus 1 into minus I. Because divided by I, what we have taken? Multiplied and divided by I. So that multiplied by I divided by I square is minus 1. Hence minus has come here, minus y, minus I. Okay. This is the value of x. This can be further simplified as if you put a what you call general solution, we can say x is equal to 2n pi, because adding 2n pi, n is equal to 1, that is a cyclic. So that every once a circle is completed, it is the angle gets multiplied by pi, 2 pi, plus or minus I into ln e plus or minus square root of e square minus 1. If a general solution is asked for. If a general solution is not asked for, you can write this. If the solution is asked for in what you call cos hyperbolic x, then in that case we can write this is cos hyperbolic inverse e. Cos hyperbolic inverse e. This value. So that the final will be 2n pi plus or minus I into cos hyperbolic inverse e. This is another solution. That means same form. For cos hyperbolic, please refer to your textbooks. What is the definition? From there, you got the cos hyperbolic inverse e is equal to ln e plus or minus square root of e square minus 1. Now, we got the solution for this in complex plane even if cos x is equal to more than 1. What we have taken here, please see the beauty, complex analysis. Cos x cannot be more than 1 in real line, but cos x is equal to e has a solution in complex plane. That solution is given by x is equal to 2n pi plus or minus I into ln square root of e plus square root of e, not here, it is not square root here, ln into ln of e plus, here it is not plus or minus, we will remove here, this we will write it as e plus we can write e plus or minus also, no problem, we will write ln e plus square root of e square minus 1, because plus or minus we have shifted to the other side, 2n pi plus or minus, hence plus or minus inside is not required. Then this is the value of the solution, or this can also be written as 2n pi plus or minus I into cos hyperbolic inverse e. Just see how beautiful the solution is, and never say that cos x will not have a solution. Universal statement never make it. Cos x, if it is greater than 1 also, if it is equal to E, there is a solution in the complex plane. But there is no solution in the real. There is no real solution, but it has a solution in the complex plane. Okay, this you please remember. For emphasizing this only, I have given this problem. Best of luck to everybody. Thank you for listening to me. Thank you for seeing this lecture, and please subscribe to my channel. If there is a value addition to your knowledge, please subscribe to my channel Maths and Science by IITian. Thank you. Best of luck. Please share and subscribe.